We need to talk about a transistor load line today. This is Tom Lieurance with Columbia Gorge Community College. We have a circuit here that is a common emitter circuit. That's common emitter because the emitter is stuck on the common. We need to plot the curve of this circuit, the load line, on this characteristic curve for the transistors, for this transistor. We're assuming this has a gain, a beta DC of 100. This load line says IB is 10 milliamps here, and IC is 1 milliamp, so that would give us a beta of 100 if IC is equal beta DC times base current. Here we have a load line. This load line is, this transistor characteristic curve. If we look at this part of the curve, we have a 10 milliamps. We have the active region right here. And in each case, the active region is this. We have breakdown, and we have saturation. And down here, right next to 0 milliamps, almost no current, we have cutoff. Now, cutoff is listed in the data sheets as to how much leakage current will be from collector to emitter if there is no base current. That's what this IB is equal to 0 is. Now, if there's no base current, the 3904 has about 50 nanoamps of leakage current from collector to emitter. And the test conditions are given on the data sheet also. What we need to do is to plot the load line for this circuit here. The first thing we do is look at this circuit, and we say, what if I have a short from here to here, and what is the maximum amount of current that can be in this circuit when VCE equals 0? When VCE equals 0, IC would be equal to 30 volts over 5k ohms. Okay, so this is what they call a mental short. Put an R in there. And we start that out. It starts at about 5 milliamps right here. And so we've plotted one point on the line. We need to plot the other point on the line. The other point deals with what's called a mental open. Next thing we need to come up with is the second part of this load line. Let's go with the red. Mental open, which means remove the transistor. What would be collector to emitter voltage if the transistor was open from collector to emitter? If we have no current flow, we have no IR drop. So it would equal 30 volts. So the second part of this load line would be right down here. And first part was right there. So what we need to do is to draw a straight line from here to there, and we end up with the load line. Now, for any transistor, actually for any operating point, any transistor we put in here should fall on this load line somewhere. The operating point for this one, let's see if we can figure it out. Yeah, oops, I changed this from 3 megohms to 1 because 1 makes it come out better. So anyhow, how do we find out where the operating point is on the load line? We have to find out find VCE. So let's find out what kind of current, how much current is flowing from collector to emitter. If beta DC is equal to 100, then we need to find IB. So IB is equal to VCC, V collector current, divided by, oh gosh, it's not VCC, is it? It's the voltage from here to here. So we're going to have to undo some of this. What would be the voltage drop across this device? We have a 0.7 volt drop at the base to emitter junction, so IB is equal to 30 volts minus 0.7 volts divided by 1 meg ohm, and that is equal to 29.3